Okay, so let's jump into this. When you hear space physics, I bet you think, you know, astronauts, maybe distant galaxies,
Yeah.
stuff that's happening way out there.
Right, super academic, maybe even sounds a bit, well, irrelevant to your daily life, like your commute or
You
getting
know,
phone signal.
exactly. But that's the surprising thing we found in the source material for this deep dive.
Yeah, it turns out space physics isn't just about the cosmos. It's actually uh, fundamentally tangled up with your life right here, every day.
So our goal today is really to unpack those connections, show you how understanding what's happening between, say, the sun and Earth is vital for the tech you rely on.
Definitely. And maybe the best place to start is with something that's probably in your pocket or nearby right now, your phone.
Or the car you drive, yeah.
Your phone, your car's navigation.
Absolutely. Like GPS navigation, streaming stuff on your phone, even satellite internet. You just kind of expect it all to work perfectly instantly.
But those signals coming down from satellites are surprisingly vulnerable. They can be affected by what we call space weather.
Space weather.
Yeah, the sun isn't static. It's always sending out charged particles, energy. And sometimes you get these big bursts, solar flares, CMEs, coronal mass ejections.
Right.
And when that stuff hits Earth's magnetic field, it can trigger geomagnetic storms.
So, wait. Bad weather in space can actually mess with my GPS down here?
That's exactly it. These storms, and just solar activity in general, can stir up the ionosphere.
The ionosphere. That's the layer high up, electrically charged.
Right. And radio signals, including GPS signals and comms satellite signals, have to pass through it or sometimes bounce off it. If the ionosphere is disturbed by space weather, those signals get, well, bent, delayed, even absorbed.
And that bending or delay means my GPS map is slightly off, or my phone signal drops for a second.
Precisely. It introduces errors.
Yeah.
But this is where knowing the space physics helps. Scientists study these interactions, Sun-Earth stuff, build models.
To predict it.
To predict it, and also to understand how it messes with the signals.
Yeah.
And that lets engineers build better systems, more resilient ones.
Systems that can maybe even correct for some of that interference.
Exactly. They build in corrections based on understanding the physics. That's why your GPS is generally so reliable for your car, or even for, landing planes and guiding ships.
That's incredible. That signals from space rely so much on knowing the physics between here and there.
Mm.
Okay, let's shift gears. From your pocket to something much bigger, the power grid.
Yeah, keeping the lights on feels pretty grounded, doesn't it?
Totally.
But this is a really critical piece of infrastructure. Those same big geomagnetic storms we just talked about, they can actually induce powerful electric currents right here on the ground.
Induced currents in power lines. How?
Well, think of the storm causing Earth's magnetic field to fluctuate wildly.
Mm-hmm.
That changing magnetic field generates voltages in long conductors, like our power lines. It's basic physics, like electromagnetism.
Okay.
But these aren't the normal AC currents the grid uses. They're more like quasi-DC currents. And they can overload transformers.
Push them too hard.
Yeah, push them way beyond what they're designed for.
Yeah.
They can overheat, get damaged.
Seriously. Lead to actual blackouts.
It's happened. Major storms have caused significant outages.
Yeah.
But again, understanding the space physics is absolutely key here.
For prevention.
For prevention and resilience, it helps engineers design grids that are tougher against these induced currents. And maybe even more importantly, it allows for early warning systems.
Like a space weather forecast.
Exactly. Utilities monitor these forecasts. If a big storm is coming, they can take steps, maybe take some equipment offline temporarily to protect it.
Wow. So it's proactive.
Yeah.
Okay, what else? Are there other in-techs we might not think about?
Oh, definitely. Think about the satellites themselves. The ones monitoring Earth's weather, climate data, they need protecting too.
Or from what?
From space radiation, high-energy particles from the sun, from deep space cosmic rays. Understanding that radiation environment is crucial for designing shielding so the satellites, survive and function properly.
And I guess that's even more critical for humans in space. Astronauts.
Absolutely vital. Predicting solar flares, knowing when a burst of radiation is coming, lets missions take shelter. It also dictates how you design the spacecraft shielding itself.
Right.
And, it even affects older tech, like HF radio, high frequency, still used by planes, military ships for long-distance comms.
Bouncing signals off that same ionosphere layer.
That's the one. So space weather impacts its reliability too.
It's fascinating how this research into something so sort of out there drives practical innovation down here.
Yeah, that's a huge point. When you push the limits to understand the space environment, you have to invent new stuff.
Right.
Like sensors that can survive intense radiation, materials for extreme temperatures. the incredibly complex computer models needed to predict space weather.
Right. The computing power must be immense.
It is. And often, these advancements, the miniaturized parts, the tough electronics, the data processing tricks, they find their way into other things, spin-off technologies.
Into consumer goods, things we use every day without realizing the connection.
Exactly. Stuff that benefits us all, even if space wasn't the initial goal for that specific bit of tech.
So it really sounds like space weather forecasting, like you said, a weather report, but for space is becoming just, well, essential for how we live now.
It really is. Increasingly so. Just like knowing a hurricane is coming helps people prepare on the coast.
Knowing a geomagnetic storm is coming helps to
Airlines.
power companies, airlines, satellite operators, even farmers using precision GPS for planting. Anyone relying on these technologies needs to know so they can mitigate the risks, protect their systems, limit the economic damage.
So, okay, the takeaway here is pretty clear then. Next time you grab your phone for directions, or just flip a light switch, or even check the weather,
Uh-huh.
none of it would work quite as well, maybe not at all sometimes, without us understanding something that seems as far away as space physics.
Yeah, from the grid keeping your lights on to the GPS guiding you, the phone connecting you. Space physics is this, like, silent partner underpinning it all. Critical, but invisible most of the time. It really makes you think, doesn't it? If we're already this dependent on space tech for, well, almost everything in modern life, what does that deep reliance on understanding space physics actually mean for our future? For how resilient we are?